The states of matter, that is solid, liquid and gas, they are interconvertible. That is the speciality of these three states of matter. In a matter, the amount of substance that is present in the matter is defined as your mass. Physical properties are properties that can be observed without changing the identity or composition of the substance. So what is volume? Amount of space occupied by a substance is called as volume. Hello everyone, I am Ambali Unnikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today we are beginning with the first chapter of your first PUC, that is some basic concepts of chemistry. So whenever you are going to study about any higher topics, let it be in chemistry or physics, you need to be clear with your basics, right? So as the name suggests, you will be studying some basic concepts. Yes, some basic concepts of the chemistry. So I hope you continue with the energy and excitement that you have in the beginning till the end of this year. Okay, so let's not waste more time and let's begin with the chapter. Yes, so today we'll be discussing about what is chemistry, the importance of chemistry, the nature of matter, classification of matter, and the properties of matter and their measurement. Yes, so let's begin with the basic question. What is chemistry, or what is the importance of chemistry? Yes, so the branch of science that studies the preparation, properties, structure and reactions of material substance is called chemistry. Chemistry is the science of atoms, molecules and their transformation. Yes, atoms, molecules and their transformations. So we will be studying in the molecular level what is matter made of. Yes, atoms and molecules and their transformations, right? Yes, so let's take the example. When you feel sick, you go to doctor, right? He prescribes you with medicine. You take the medicines. Yes, what happens? The constituent particles in the medicines reacts with your body. Some transformations takes place, some reactions takes place, yes, and that cures the disease. Right? So not only in the case of medicines, everywhere in and around you, you are able to see a lot of chemical reactions taking place. Yes. So what happens in there? The atoms combine together to form molecules. They undergo transformations. They undergo reactions. Yes. And that is how you are able to see the changes happening around you, or whatever products you are able to see, the matter that is made up of these atoms and molecules. Right? So chemistry deals with the atoms, molecules and their transformations. Yes, so starting with the basics, what is matter? Yes, so from your early classes itself, you are studying this. What is matter? Matter is anything which occupies space and has mass. Yes, this is nothing new, which has already been studied from many classes, right? Yeah, so matter is anything which occupies space and has mass. So there are three states of matter which you have studied till now, that is solid, liquid and gas, the three states of matter. And there are two more which are being discovered, that is plasma, the photo you can see here, and the Bose-Einstein condensate. So in here we'll be discussing only the three states of matter, that is solid, liquid and gas. Yes, so solids are said to have definite shape. Right? They have a definite shape. Let us take the example of the pen that I am holding. Yes, it does have a definite shape, right? And it has a definite volume also. Yes, it has a definite mass. Yes, it has a definite volume. Okay. Now they are highly incompressible. Yes, if I am trying to compress it, we are not able to compress it, right? So they are highly compressible substances, solids in general. Now let's move on to liquids. They do not have definite shape. So what is this? They do not have definite shape. Let us assume that you are taking some liquid, let us say water, in a water bottle. Yes, in that condition, the water or the liquid will occupy the shape or will transform into a shape of that bottle. Now, exact amount of water, I am transferring it into a glass. So what happens? Now the liquid will move, or the liquid will transform into a shape of the glass, right? So it doesn't have a definite shape. It occupies the shape of the container in which it is present, right? Now the next one is definite volume. Yes, even if I change the liquid from the bottle to the glass, the volume doesn't change, right? The volume remains a constant. So that is definite volume. Incompressible. Yes, not to the extent of solids, but liquids are also not that compressible. That's why we term it as incompressible. Now let's move on to gas. Do they have a definite shape and volume? No, right? They do not have a definite shape. You can't say that the gas is having a round shape or a spherical shape, right? So they do not have a definite shape. And what about volume? They do not have a definite volume as well. Yes. And gases are highly compressible, right? The liquefied petroleum gas or the compressed natural gas, the LPG that you use as your domestic fuel, and the CNG that is used in automobiles, all these are compressed under very high pressure. Yes, so gases are highly compressible. See, as you can see in the picture that is given here, the solids are packed very tightly here. Yes, so they are not compressible. The liquids, a little more gap is present. Yes, and in the gases, it is really or highly compressible. Yes, I hope till here it is clear. Now, let's move on to the next one. That is, states of matter are interchangeable. So, the states of matter, that is solid, liquid and gas, they are interconvertible. That is the speciality of these three states of matter. The three states of matter are interconvertible by changing the conditions of temperature and pressure. So, once you change the temperature or pressure, you will be able to obtain each three of them. That is, they are interconvertible. So let's begin with the diagram. Yes, so solids can be converted to liquids by the process which is called as fusion. Yes, solids are converted to liquid by the process which is called as fusion. So can you take an example from your day-to-day life? Solid is getting converted to liquid. Yes, ice. Ice melts and it gets converted to water, right? So if you take ice from the fridge and keep it under room temperature, what happens? Your ice will start melting and finally you will get your liquid, right? A liquid, that means water. Yes. So that is the process, conversion of solid to liquid. Now liquid can be converted to gas. How? Yes, this is discussed. Now liquid can be converted to gas. The process is called as, yes, vaporization. The conversion of liquid to gas is called as vaporization. So an example for this will be, yes, when you boil water, right? What happens? You boil water, the water gets converted into water vapor. Yes, that is an example for liquid to gas. Now, what about gas to solid? Yes, what about gas to solid? Yes, this process is called as deposition. The process of conversion of gas to solid is called as deposition. Yes, can you state an example for this? Yes, so an example for this can be frost. So what is frost? So in very cold climates, when the gas, the atmospheric gas, comes in contact with the window panes, it gets converted into ice. So that is called as frost. So you can see ice particles there. So the gas gets directly converted into solid, which is ice. Yes, this happens in very cold climate when the atmospheric gas comes in contact with your window pane and the gas gets directly converted into ice. That is called as frost. So yes, I hope that is clear. Now let's go in the opposite direction. That is, can solid be converted into gas? Yes, solids are converted into gas by the process which is called as sublimation. Yes, so an example for this is naphthalene balls, the white colored balls that you have seen in your cupboard. Yes, so to prevent the attack of insects, right? So these naphthalene balls, they are solids. Yes, what happens is after a time, this solid naphthalene balls gets directly converted into gas. They do not go into liquid state. They get directly converted from solid state to gaseous state. Yes, so I hope that is clear. Now, gas is getting converted into liquids. That is, or the process is called as condensation. Gas getting converted to liquid. Now, what is an example for that? Gas getting converted to liquid. Yes, when you take a cold glass of water and keep it in front of you, yes, what happens? After some time, you are able to see liquid droplets on the walls of the container. So, what is happening? Yes, the atmospheric gas comes in contact with the cold glass of water and it gets converted from the gaseous state to the liquid state. So that liquids are the liquid that you are able to see on the walls of the container. Yes, same case, another example that you can take is if you are boiling water and you are taking or closing it with a lid. Yes, what happens? After a while, you take the lid and you observe it. You can see that the water vapor, once you boil the liquid, the water gets converted to water vapor. That comes in contact with the lid and the gas gets converted to liquid state. So the liquids that you are able to observe is because of the condensation process that is happening there. Yes, now the conversion of liquid to solid, which is called as solidification. Now for this also a very easy example is you take water and you keep it in fridge. What happens? Yes, it becomes ice, right? So the liquid gets converted to solid. So from here, I hope it is clear that yes, matter are interconvertible. So you are able to convert these three states of matter, that is solid, liquid and gas, with each other by changing the conditions of temperature and pressure. Yes, so the conversion of solid to liquid is called fusion and the reverse process, that is the conversion from liquid to solid, is called as solidification. Now the conversion of liquid to gas is called as vaporization and the reverse process is called as condensation. Yes, now the conversion of solid to gas, yes, in this case there won't be liquid state, right? Is called as sublimation and the reverse process is called as deposition. Yes, now let's move on to the next one, that is classification of matter. Yes, how do you classify matter? Matter is classified on the macroscopic level into pure substances and mixtures. Yes, and the pure substances are further classified into elements and compounds, and mixtures are further classified into homogeneous and heterogeneous mixtures. Okay, yes, I hope it is clear. So let's begin with pure substances. When all constituents of a substance are same in chemical nature, we call it a pure substance. So pure substances are having uniform composition, or you can also say that they are having fixed composition, right? They are having fixed composition. Yes, so they are substances which are having fixed composition. Let's take the example of gold and water that you can see. Yes, in gold, only gold particles will be present and the gold atoms will be present in a fixed amount or fixed composition, right? And in the case of water also, from wherever you take water, yes, that is H2O, from any source you collect water, the ratio, that is the ratio between hydrogen and oxygen, that is 2:1, will be fixed from wherever you collect your water. Yes, so they are pure substances. They are classified further into elements and compounds. So elements are pure substances which contains only one type of atom. Only one type of atom. So gold is an example of element because it only consists of gold atoms, right? Yes. Now what about compounds? They consist of more than one type of atom. So yes, water becomes an example for compound. Why? It is made up of two types of atom like hydrogen and oxygen, right? So they are considered to be compounds. Yes, so I hope it is clear what is elements and compounds. Now the properties of a compound could be different from those of its constituent elements. Yes, the properties of compound could be different from those of its constituent elements. So what does that mean? Yes, so water is made up of hydrogen and oxygen, right? So you know that hydrogen and oxygen exist as gases. Now what about water? It exists as a liquid, right? So So that is what is written here. The properties of a compound, that is your water, need not be or will be different from those of its constituent particles, that is hydrogen and oxygen, right? And hydrogen and oxygen are considered to be those substances which promotes combustion. Yes, and what about water? It extinguishes fire, right? Yeah, so they are having different properties, right? So that is about pure substances. Now let's move on to mixtures. So mixtures are substances that contains two or more pure substances present in any ratio. Yes, in the case of pure substances, the components are present in a fixed ratio. But in the case of mixtures, it contains two or more substances which are present in any ratio. Yes, so when the word mixture, you hear the word mixture, the first thing that comes to your mind will be this mixture. Right? Yeah. So you can see there are peanuts, this yellow colored thing, curry leaves are there, whatever substances that you can add, it will be present in the mixture. Right? Is there any fixed ratio there? No, right? So the peanuts can be more, this yellow color stuff that you can see, that can be more, right? There is no fixed ratio. Yes? So now mixtures are further classified into homogeneous and heterogeneous mixture. So homogeneous mixtures are mixtures having uniform composition. Yes, they are mixtures having uniform composition. So let's take the example where I add in sugar to a glass of water. Yes, what happens? I add sugar to the water and I mix it thoroughly, you get sugar solution. So now the obtained sugar solution, in the obtained sugar solution, are you able to see any different layers? No, right? Yes, so they are having a uniform composition. The solution hence obtained is having a uniform composition. Even though it is prepared from two different substances, now it is having a uniform composition. Now let's come to heterogeneous mixture. So what is heterogeneous mixture? They are mixtures having non-uniform composition. Let's take the example of mud and water. You will get muddy water, right? So now in this case, even if you mix thoroughly, you will be able to see two different layers. Yes, on the down part, you will be able to see your mud, and on the top part, there will be water, right? You will be able to see two different layers. Yes, so such mixtures are called as heterogeneous mixtures. So now let's move on to the next session, that is properties of matter. So properties of matter can be divided into physical properties as well as chemical properties. So first we'll begin with physical properties. So physical properties are properties that can be observed without changing the identity or composition of the substance. So you need not change the identity or composition of the substance. So an example for these can be smell or taste. Yes, so what happens? In this case, you need not change the identity. If you want to taste or smell a substance, you need not change the identity, right? So that kind of properties are called as physical properties. But on the other hand, chemical properties, a chemical change is required to observe and measure these kind of properties. Right? So if you want to measure the acidity or basicity of a substance, just by looking at it, you won't be able to measure it, right? So a chemical change or a reaction is supposed to be taken place there, then only these type of properties, that are chemical properties, will be able to observe. Okay. Now, physical properties are further classified as qualitative property and quantitative property. So as the name suggests, qualitative, quality. So these are properties that cannot be measured. You won't be able to measure it. Yes, so examples for these are malleability and ductility. Yes, quality, you will be able to observe it, the quality of it, but you won't be able to measure it. Yes, now the next one is quantitative property. So as the name suggests, quantity, quantitative property, the properties that can be measured. So the examples for these can be temperature, length, mass, all these are measurable properties. So such properties are called as quantitative properties. Now, till here we have discussed that quantitative properties are there, qualitative, physical and chemical properties we discussed till now. So all these quantities, if we need to measure it, of course there must be some units to represent it. Yes. So if I am telling that this pen, the length of this pen is 2. What is 2? You need some unit to represent it, right? Is it 2 centimeter? Is it 2 meter? Is it 2 kilometer? Yes. Hence, there comes a need to introduce a internationally accepted system of units. So, not just in India, this system of units will be accepted internationally, right? So, regarding that, we are going to discuss now. So, that is called as SI system, which is universally accepted. That is a system of unit which is universally accepted. So, the full form of SI is System International. Okay. Now, the SI system has 7 base units which pertain to 7 fundamental quantities. Okay. So, the SI system has 7 base units that are being mentioned here. So, the first one is length. The symbol for the quantity is L and the name of the SI unit is meter and the symbol for it is small letter m. Yes, this is already familiar for you. Length. The next one is mass. The symbol of the quantity is m. The SI unit is kilogram. Even though we measure it in grams, mostly in chemistry, you measure it in grams or milligrams. The SI system for it is kilogram, which is represented as kg. Now, time, the symbol for the quantity is small letter t. The name of the SI unit is second, represented by small s. Then there is electric current, which the symbol for the quantity is capital I. The name of the unit is ampere, represented by capital A. Temperature, capital T. The name of SI unit is Kelvin and the symbol is capital letter K. Now, for amount of substance, the symbol of quantity is small letter n and the name of SI unit is mole and the symbol is MOL. Yes. So, here the name is MOLE. The symbol which is used to represent it is MOL. So, regarding this mole, you will be studying in the upcoming sessions, okay, which is a part of this chapter. In detail, you will be studying about mole and mole concept. Yes. Now, the last one is luminous intensity, represented by IV, and the name of your SI unit is candela, represented by the symbol CD. So, these are the 7 base units that come under your SI system. Okay. Now, let's begin with mass. Okay. Now, what is mass? Mass is the amount of substance present in it. So, in a matter, the amount of substance that is present in the matter is defined as your mass. Now, the mass is a constant value. Even if you are in Earth or you go to moon, your mass will be same. The mass is a constant. Okay. And the SI unit of mass is kilogram. Yes, as I said, it can be measured in grams or milligrams or any units as such, but the SI unit for it is kilogram. Yes, now there always comes a confusion whether mass and weight are the same. No, mass and weight are not same. So, you're clear with what is mass. Now, what is weight? So, weight is actually the force exerted by gravity on an object. Okay, so mass is the amount of substance present and weight is a force. Okay, weight is a force which is being exerted by gravity on an object. So, your weight is the mass multiplied by acceleration due to gravity. Yes, so weight may vary due to the change in gravity. That means, as I said, in the case of mass, there won't be any change of mass even if you are in Earth or you go to moon. But what about your weight? Yes, acceleration due to gravity. The value for G is different in moon, right? The gravitational pull of moon is very less as compared to that experienced in Earth. Yes, so your weight will change once you go to moon, right? So the weight will be less. So it is not a constant and the SI unit for weight is Newton. As I said, it is force. That is the force exerted by gravity on an object. So the SI unit will be Newton and not kilograms. So I hope you're clear with the difference between mass and weight. Now let's move to the next one, that is temperature. The 3 common scales which are used to measure temperature are degrees Celsius, Fahrenheit and Kelvin. These are the 3 common scales that are being used: Celsius, Fahrenheit and Kelvin scale. So Kelvin scale is the SI unit. Out of these three, Kelvin is the SI unit for temperature, which is represented by the symbol capital K. Now, temperature below 0 degrees Celsius are possible in Celsius scale, but what you have to remember is in Kelvin scale, negative temperatures are not possible. So, you are able to obtain, let us say, minus 25 degrees Celsius is possible in Celsius scale, but you won't be able to obtain negative values in your Kelvin scale. So, this two equations that I have mentioned here, this will help you to convert from one scale to another scale of temperature. See in here, if you have your degrees Celsius value, you will be able to convert it into your Fahrenheit scale. The equation is 9 by 5 into the value in your Celsius scale plus 32. Now, in the same way, if you have your degrees Celsius value, you can convert it into your Kelvin scale as well. You just have to add it by 273.15. Yes, so I hope that is clear. Now, prefix in SI unit. So, why this is necessary? So, as I said, in chemistry, you will be dealing with very, very small quantities. Let's say 0.000001. So, like this, very small quantities if you are dealing with, it is very difficult to represent it in the form of 0.0001. So, in such cases, you use prefixes. So, instead of representing it as such a big number, you can write it in the short form using these prefixes that are mentioned here. This is also accepted by the SI system. So, as you can see here, some of the prefixes are already familiar for you. Yes, you can see nano here, 10 raised to minus 9 is nano, minus 6 is micro, 10 raised to minus 3 is milli, centi, deci, all these might be familiar for you. So, let's start from the beginning. Yes, 10 raised to minus 24 is yocto, symbol for it is Y. 10 raised to minus 21 is zepto, 10 raised to minus 18 atto, 10 raised to minus 15 is femto, 10 raised to minus 12 is pico. Yes, nano, micro, milli, centi, deci. Now comes 10. Now these are the negative ones. Now comes 10. 10 is, the prefix for it is deca. 10 square is hecto. 10 raised to 3 is kilo. Yes, kilo will be familiar for you. 10 raised to 6 is mega. 10 raised to 9 is giga. 10 raised to 12 is tera. 10 raised to 15 is peta. 10 raised to 18 is exa, 10 raised to 21 is zeta, and 10 raised to 24 is iota. So, these prefixes, instead of representing it in as I said in the beginning, instead of representing it as big numbers, you can use these short forms. So, I hope that is clear. Now, let's move to the derived units. So, the question comes, we discussed about the 7 base units, right? So, as you can see here, these are the 7 base units that we discussed. So, are there only these 7 quantities present? No, right? There are many other quantities present which also needs to be represented, right? It is not just these 7 quantities. So, what about the other quantities then? So, they come under derived units. So, derived, they are being derived. The units of those quantities are derived from the 7 base units that we just discussed. So, let us consider the example of volume. So, what is volume? Amount of space occupied by a substance is called as volume. So, in the 7 base units, we did not mention about volume. So, how do you find the unit of volume? Yes, so what is volume of any substance? So, let us consider a cube. Okay, so how do you represent the volume of this cube? It is length cube, right? That is length into length into length, or you can say it as side cube, right? That will be the volume of the cube. We do know what is the SI unit for length, that is meter. Yes, so that will be meter into meter into meter. Right, so what will that will be? That will be meter cube, right? That is meter cube. So, we did obtain the SI unit of volume, that is meter cube, because we already knew the SI system of length. Clear? Yes. Now, let's take another example of density. What is density? It is mass by volume, right? So, it is the amount of mass per unit volume. So regarding this, how do you calculate the unit? How do you derive the unit from your 7 base units? Yes, mass by volume. What is the SI unit of mass? It is kilogram, right? And what is the SI unit of volume? It is meter cube. Just now we derived it. So it will be kilogram per meter cube. Yes, so I hope till here what we have discussed is clear for you. Yes. So in the next session, we will be studying about uncertainty in measurement, scientific notation and significant figures. So I hope till here what and all we have discussed is clear for all of you. So thank you.